In this video, we are going to solve a problem based on Jahn Teller distortion. The DD absorption band of FeH2O6 2+ is split due to presence of octahedral geometry, static Jahn Teller distortion, dynamic Jahn Teller distortion, and presence of trigonal bipyramidal geometry. In the given complex, I have 6 ligands. For trigonal bipyramidal geometry, we need only 5 ligands. So it is not trigonal bipyramidal geometry. Based on that, I can eliminate this option easily. Let us focus on the remaining 3 options. The first one, presence of octahedral geometry. Of course, the geometry of this will be octahedral. In this, ion is in +2 oxidation state. So it is D6 system. The ligand is water. It is weak ligand. So the electrons will be filled singly first, then pairing will take place. This is T to G and this is EG orbitals. The T to G orbitals are not symmetrically filled. This orbital is doubly filled, but these two are singly filled. Because of that, we can expect Jahn Teller distortion. Now, let us try to find out the term symbol for Fe2+. The ligand is weak, so for the weak field, we have to find out the term symbol. We have 6 electrons. Since the field is weak, I place the electron singly first, then I go for pairing. L value we have to find out. L value will be 2. Since L value is 2, the term will be D. What about spin multiplicity? There are 4 unpaired electrons. So the spin multiplicity will be 5. So the term will be D term and the spin multiplicity will be 5. This D term will undergo splitting to give T to G and EG. You can expect one transition between this. But in the problem, they have mentioned there is splitting of this particular absorption peak. When there is Jahn Teller distortion, T to G can be further splitted. We can get transition from this to this and from here to here. So we can expect 2 peaks when there is Jahn Teller distortion. Now we have to find out whether it is because of static Jahn Teller distortion or dynamic Jahn Teller distortion. What is the difference between these two? Static will be somewhat permanent. It is possible to find out the elongation of z-axis. In octahedral geometry, all the 3 axes will have same length. But when you go for Jahn Teller distortion, it is called tetragonal distortion. The z-axis will be somewhat longer or shorter than x and y. If you are able to measure the elongation or contraction of the z-axis, that is referred as static Jahn Teller distortion. Say you are not able to measure that. Say it is negligible amount or it is continuously changing. That time it is referred as dynamic. Static Jahn Teller distortion is generally exhibited by D9 system. When the EG orbitals are unsymmetrically filled, that time we get this. So for D9 system, we get this. And even when you go for D7, low spin complex, for that system also we can expect static Jahn Teller distortion. When T to G orbitals are unsymmetrically filled, we get dynamic Jahn Teller distortion. Systems like D1, D2, D6, D7. So these are high spin complexes. Even D4 and D5 low spin complexes can exhibit dynamic Jahn Teller distortion. In our case, we have D6 system. It is high spin. Since the T to G orbitals are not symmetrically filled, the Jahn Teller effect will be minimum. You will not be able to measure the elongation or contraction of z-axis. So the correct answer is dynamic Jahn Teller distortion.